Okay, hello everyone. Today our topic is about electricity 3, okay? And first part we are learning about series and parallel circuits, okay? So let's move in on this part and we are discussing about two different connecting ways, okay? So the first way is called like a series. Like here you can find, maybe here is very close to Christmas, right? And there are many filament lamps, they are connected together. And you can find once you turn on the switch or you turn on the opening, you'll find all the lamps just light in the same time, right? So we'll find, okay, maybe here the electricity just goes through these lamps at the same time, right? So we can say, oh, here the electricity travels in a very fast speed and makes them to like lit in a very short period, okay? So here we can find that you can find the lamps are connecting in just one wire, right? And you can find here it is also connected in one wire, right? So they have a way of connecting with each other. So let's discussing about how this way can make a difference, okay? So first of all, here you can find there are some lamps in series and parallel. Like here, if you find that the lines are connected together from the left to the right, we can consider here and just lamps are connected in series. Okay, so like here, and here lamps just lead together because this way has electricity. That means electrons can transfer through these paths, right? So both lamps has the electrons to transfer to traveling, so they can both lead together. Okay. And in the second figure, you can find there are two lamps, right? And the two lamps they are connected in parallel. You can find there are two parallel lines right here, right? This one and this one, right? So we can call this parallel lamps, okay? And for battery, we can find that it is also paralleled with two lamps, right? So here we can find there is a very interesting two different connecting method. So first we are moving on or focusing on how the connecting in series will have a difference. Okay, here, like here. So you can find if you add a switch, we can produce and we can protect the circuit, right? And if you want to just lit one light, you can just control it. Okay. Okay, so first of all, it's about how to connect into series, okay? So here there are two resistor, and you'll find this is 3 ohm and this is a 6 ohm resistor, right? And last day, we have already discussed about if you connect it into series, and here there are the same current on the same wire like this way, right? They're both or they're all 2 ampere, okay? So there are two ampere, and maybe you are using the ohm law like U equals to I times R, right? The voltage equals to current times the resistance, right? So here you can say, oh, here U equals to I times R, and here U like equals to 3 ohm times 2 ampere, right? So here the final answer is 2 voltage, okay? It's 2 voltage. So here for the first resistor is 6 voltage. And you can find in the second resistor, if here a 6 ohm and using the 2 ampere, you can times it together. Then 6 ohm times 2 ampere equals to 12 voltage. So here, the final answer is 12 voltage, okay? And then you can make them at like an addition, like 2 voltage plus 12 voltage equals to 18 voltage, like this way. Okay, so this is for the basic circuit rule, right? So maybe here you have some question about this, but we can just consider it as a river stream, right? So if you just consider it as a river stream, and 2 ampere means that in 1 second that it passes through 2 charge, right? Like this way, okay? And for each charge that passes through the maybe a resistor, like a very big stone, it blocks the way, right? So we said that here has a height difference. Like here, there's a height difference of H1. And maybe here and here, it has 2 points and height difference of H2 between each other, right? So we can say, oh, from the beginning point to the final point, there are a difference, right? You can find from the first point to the last point, the total height difference is H1 plus H2, right? So we can say H1 plus H2 here equals to 18, H1 equals 6, and H2 equals to 12, okay? So I guess it's not very difficult for you, right? So in the like connecting to series, we can say that current in the series equals to each other. And we can also say that here that the potential difference can divide it into two parts, or total potential difference that made of the two resistor, okay? So here you can find this is a very interesting conclusion for the connecting to series part, okay? So maybe if you connect it into parallel part, like here, we have a 3 ohm resistor and here's a 6 ohm resistor, right? And we said before, like the current is like a stream, right? So you can consider here, line ampere means like, same time or in just 1 second, it passes through 9 charge. And on the first pass, maybe here, it can divide it into 6 charge like this. And in the second pass, it can like passes through 3 charge like this, okay? So if there is 3 ohm, and we can say, oh, like using the formula, Ohm's law, right? U equals to I times R. So here the voltage of this is U equals 3 ohm times 6 ampere equals to 18 voltage, right? So here's 18 voltage. And right here you can find if there is 6 ohm and here's 3 ampere, total voltage here is 3 ampere times 6 ohm, it equals to 18 voltage, right? So you can find that the two resistor has the same voltage or same potential difference between the two sides, right? So maybe you can set here, oh, the U1 equals to U2 because they have the same potential difference, right? And maybe for the I total can divide it into two parts, I1 and I2, right? This is for the conclusion, okay? So also we can using the stream to describe this, right? The stream is divided into two parts. So the total value of the stream or the total drops of the water in the stream doesn't change, right? And secondly, you can find here from the A point to the B point, whether you choose different paths that they have the same potential difference or they have the same height difference, right? So we can say, oh, here they have the same difference. So from this to from this, they have a difference of 18 like meter like this way. So we can both say that they have the 18 voltage on their two parts, okay? Okay, so here's the lamps in the series and parallel. Right here, you can find, oh, for this maybe for this battery, and there are three 1.5 voltage battery connected together. So we can say, oh, right here, that they are connected in series. And if you consider here is 0 meter like a stream, and here's 1.5 meter, here's 3 meter, and here's 4.5 meter, right? Like a pump to water pump to pump all the waters upward, right? So total for here is 4.5 voltage. And maybe here, if you added one negative 1.5 voltage, that means it reverse, right? And the total here is 1.5 plus negative 1.5 and plus 1.5 voltage. So total here is 1.5 voltage, okay? And here you can find, if you connect it into parallels, that three battery just have the same potential difference. They're both, or they're all 1.5 voltage, okay? Okay, so please just try to do this exercise, please, and try to determine what is the readings on the T ammeter and trying to understand which is can take place and maybe the voltmeter and how to measure this. Okay, try to do this problem, please. Okay, so this problem is not very difficult, right? So for this ammeter and the reading is 4 ampere, and here just divided in two parts, and here the reading is 2 ampere. And maybe here the reading is both, all like it is also 2 ampere, right? Because we said that maybe here 4 ampere means 4 drops in the stream, and it's divided into two parts. The first part is 2 drops in the stream, and second part is also 2 drops in the stream, right? So we can say, oh, right here, that is passes through the total part, and is 2 ampere and is 2 ampere, right? So here we can say they're both 2 ampere. Okay. And B, if the potential difference across the battery is 6 voltage, and what is the potential difference across each of them, right? And it's not also not very difficult. Like if you just consider here 6 meter and here's 0 voltage, and here is also 0, right? We said that like a wire that doesn't take place or doesn't has any potential difference, right? So here's also 6 voltage, and here's also 6 voltage because they're connected in parallel. We said that the two sides of the lamp maybe here the potential difference equals to the same value, right? So they're both 6 voltage, okay? So I think this problem is not very difficult, right? Okay, so this is for today's our lesson. So see you next time. Bye.